Okay, so a lot of times I start these videos by saying this is going to take 10 minutes, 15 minutes, whatever, and it ends up taking like 2 hours. So I don't know how long this is going to take. It might take 30 minutes. It could take an hour. Who knows? So whatever. Hopefully you watch all the way. Hopefully you learn something, and hopefully this video is somewhat helpful to anyone that's wanting to set up high availability and virtual IPs on two pfSense nodes. Okay, so this is not going to get into if you're setting up a cluster, but if you just have two pfSense nodes that you want to set up in high availability, this will be the video for you. I really hope that you enjoy this. So there are a couple things that you need to understand before you dive into this process. You can't really take two totally different servers and make this work easily. You can make it work. It's going to be a little bit more difficult, but it's much easier if you have identical hardware, identical network interfaces that are using the same drivers, and it's just going to help you along the way, because what you have to do, no matter how many interfaces and VLANs that you are going to use, you have to set up the secondary firewall exactly the same way that you do the primary firewall. So you even have to do things in the same order. If you assign interfaces that are on different VLANs and you go to the secondary firewall, you have to assign them in the same order that you did, even if the primary firewall, you delete an interface and keep adding more, the number of the interface will actually jump. Okay, so basically what I'm trying to say is when you set the primary firewall up, remember in what order you do things, and there's a good way for you to actually sort of check in what order things are going. If you go to status and you go to interfaces, you will see WAN EM0 or whatever your driver is, LAN EM1, and then OPT1 I have set as my sync interface. So the more interfaces you add, whether you're adding VLANs or whatever, this number OPT1 will just increment to OPT2 for the next one, and then OPT3 and 4, 5, or however many interfaces that you have. So if I had another interface and it was down here, OPT2, and then I came back and deleted the sync interface, the other interface would still be OPT2. Okay, so just make sure that you sort of follow along and check on these things. And what I've had to do in the past is if I had a firewall that had been in service for a while, and you've maybe deleted interfaces, you on the secondary firewall could just create a dummy interface and then go back and delete it just to advance the OPT counter to the next one. There are ways to work around that. The pfSense documentation does mention that you could potentially use a lag interface to sort of get around that limitation. But to make it a little bit more straightforward, I'm just going to show you how to do it this way. And the documentation really just recommends that you just remember what order you do things in and set up the secondary firewall the exact same way. And it does matter, because when you do the sync from the primary to the secondary, your firewall rules will actually follow along here. And if you have a different network set up on OPT1 on your secondary firewall, you're still going to get OPT1's originating firewall rules. And that's probably not going to work out very well for you. Okay, so again, just make sure that when you go here and compare the two interfaces and VLANs, whatever you have set up, that your interfaces actually match. Okay, so very important. I wish there was a way to sort of like remap the interfaces, and like when you're talking about high availability and pfSync, it would be nice if they had that feature, but right now they don't. Okay, so Netgate basically just says, just make sure you do them in exactly the same order. Other things that will not sync. Basically, most things in advanced, they're not going to sync. All right. So anything in here, any system tunables, that type of thing, you're going to have to go ahead and manually put them in over here. Things that do sync, one more thing that doesn't sync, your packages that you install, and the gateways and stuff like that don't sync over. So pretty much anything in the system tab is not going to. And there are other things too that I don't think sync, like snort, all the rules and all your lists and stuff like that. I don't think that those sync over. So you sort of need to set up all of the snort interfaces again on the secondary firewall. So things that do sync would be things like firewall rules. So all of the interfaces will actually migrate over to the secondary firewall, which is kind of nice. DNS entries, DNS forwards, that type of thing. If you go to the DNS forwarder here and you manually, put in host overrides, those will copy over. That's very nice. VPN, the OpenVPN and IPsec, and I haven't tried L2TP, but I assume it would probably work. All of your setup here would sync over. Certificates will sync over. That's very nice. And one thing to make sure that you don't forget is the authentication servers are in system, so those will not transfer over. So you'll have to, if you're using Radius or Active Directory, LDAP, whatever, you'll have to go into the secondary firewall and set that up as well. All right, so, but you can look at the documentation and sort of figure out what is going to sync and what's not going to sync. That's just a sort of a brief rundown of what you're going to get automatically on the secondary firewall. The documentation also recommends not really calling the firewalls like primary and secondary, or I guess I should say master and slave. They really don't want you to visualize it like that. It's sort of like, it's not really like back in the day when you had like NT4, domain controllers and stuff like that. You always had a primary domain controller and a backup domain controller. That's sort of the way that this is geared. So you can just do A and B, 1, 2, whatever. You do in a 2-node setup, you basically do have your primary firewall online all the time, ready to go. It's the one that's utilized. The backup server is basically just sitting there, receiving heartbeats and checking the gateways, that type of thing, to see if it needs to report back to the primary that, hey, I'm having a problem, so I'm actually going offline. It's really not handling traffic out of the box. So don't think that if you set up a secondary firewall in high availability that you're going to like double your speed, or that you'll connect to your ISP through 2 firewalls and it's gonna load balance between the two, because it's not going to do that. That's not really what the high availability is geared to do. It's mainly being able to take one of the 2 firewalls totally offline, sever the cable, unplug it, shut it down, restart, whatever, and the virtual IPs that are running on both of these should still be maintained by the one that is online. And really the clients, when it comes to everyone that's connecting through the virtual IPs, they really don't see a change. The MAC address, the virtual MAC address, is the same. The IP is still online. So you may, if you're running a VoIP application, you may have a dropped call or something like that. I haven't really tested that, but I guess technically it's possible that you could even sustain the call, because another thing that does sync is all of the state synchronization. So I'm actually going to go ahead and pull this up here. If we go to high availability sync, so these are all of the things that will sync right here. And so captive portal is nice if you're doing, you know, vouchers. All of the roles and all the vouchers will move over, and as they're used, will sync over to the secondary server. And so what we're going to do is go ahead and take a look at this text file over here that I created, which basically just gives you the breakdown of the WAN interface that we're going to use, and what the VIP is actually going to be. So you'll notice that I've got 56.2 here on the primary and 56.3 here on the secondary, which we've got here. And the virtual IP 56.1 doesn't exist yet. Okay, so we will go ahead and set that up as well. And then I just went ahead and put in here that I've got the two IP addresses set up for the sync interface, which you can see here on sync. All right, so the sync interface, I can't remember if I've already said this or not. The sync interface it basically needs to be its own dedicated hardware. It can run on a VLAN, that's fine, or it can be untagged, whatever you want to do. The most, I would say, foolproof way of connecting the two sync interfaces, you know, physically between the primary and secondary firewall, would be a crossover cable. You just plug it into the dedicated interface on pfSense 1 and then plug it into pfSense 2. There's no switches involved. It's direct communication, and that's one less thing to fail. Okay, so if you don't have a dedicated interface for pfSync traffic, you could throw it on a VLAN, and it's probably going to work okay, as long as this isn't a huge, large-scale environment where tons of interfaces and VLANs are set up and there's a lot of traffic being sent back and forth, and heartbeats for every single interface, that type of thing. You may run into a problem if you're throwing that traffic on an interface that's already doing a lot. Okay, so if in doubt, get some extra interfaces, get some network cards, throw in the server, and just use a dedicated interface. Okay, so you could also connect the dedicated interfaces to a switch, and then just make sure that the switch is configured correctly. You could use a managed switch, an unmanaged switch, doesn't really matter, because it's not, there's no special traffic that's actually flowing through this private network. There's no jumbo frames, there's no need for DHCP snooping and all that fun stuff. It can just be a dumb switch. It can be unmanaged, like I said, but it does need to be secured, because a lot of the traffic that is riding on this network is very sensitive, and you don't want it to end up in the wrong hands. So with that being said, I think we've covered the sync interface, and let's see. So, and by the way, the sync interface, you can pick whatever IPs that you want, as long as they're in their own subnet. All right, so I just kind of just made that up. All right, 10.50.0.1 and 10.50.0.2 for the secondary. There is no virtual IP for the sync interface, because this network and these two interfaces is just for the two firewalls to talk to each other. All right, so these are not accessible outside, or they shouldn't be accessible outside of the physical network and even the virtual network that these two machines are running on. Okay, So that's why there's no need for a VIP, because you're just basically allowing the two machines to talk directly to each other and eliminating, you know, any middlemen in the process. All right, so we've gone over the WAN IPs, the LAN IPs, and the pfSync interface. We've gone over what is going to sync and what's not going to sync. So I think the next step here is to go ahead and go into the high availability sync. And well, one thing you could do if you're using the crossover cable and you just want to make sure that everything's working, or you've got your switch programmed correctly, whatever, you could go to Diagnostics, go to ping, and from the primary, you can ping the secondary pfSync interface. So that'd be 10.50.0.2 ping. We should get a response. All right, and then from the secondary, we can go to Diagnostics ping, and we should get a response from 10.50.0.1. And if this works, then we know that they are talking to each other and everything is good there. There are some special rules that you have to put into the sync interface. I'll show you those now. And you only have to do these on the primary, and the secondary, once the sync starts, will automatically have these populated over here. And that's a good way to sort of, you know, check to make sure that the rules are actually, you know, copying over to the secondaries. Come in here and see if they are duplicated. All right, so I did go ahead, when you first create the sync interface, this rule, the allow any, isn't created, but I went ahead and put that in so I could do the ping test between the two. And per the documentation, I already went ahead and put in these three rules here. I didn't think there was any point in showing you, you know, me typing all that stuff in and selecting all the boxes, but basically just make sure that your sync interface on the primary firewall has these rules set up. If you don't have these set up, then the sync will fail to the secondary server. All right, so now that we have our sync rules in place on the primary, we should be able to go to high availability sync, and we can check the box that says pfSync transfers state insertion, update, and deletion messages between firewalls. That's what we want, all right? But the synchronized interface, WAN, is definitely not what we want. We want to choose our special dedicated sync interface that we have. All right. So the pfSync synchronized peer IP address is going to be the actual sync interface on the secondary firewall. So as we know, that is 10.50.0.2. And we will go ahead and configure the XML RPC sync. And again, the synchronized config to IP is going to be the secondary firewall. Okay, and then the remote username is going to be admin. And the documentation states that you have to use the admin account. So you can't use a different username that is also set up as an administrator in the web GUI. It has to be admin. I'm not sure if it has to be admin, why they let you choose something other than admin, but anyway, just make sure that you're using the admin account, and then make sure that you have the admin password set correctly. All right, and we're going to toggle all of these things because we're just going to copy it all. And while I'm thinking about it, this made me think of the admin portal. If you change the port that the web GUI runs on, which is it's HTTPS, so by default pfSense runs on it runs the web GUI HTTPS on 443. You can change that to whatever you want, so you can make it, you know, 460 or whatever it is. But if you change that on the primary server, you again have to go to the secondary server and make sure that the web interface is running on the same port. So you can't have one on a different port and talking to the other, okay? So again, if you do modify the default HTTPS port, make sure it's the same on the secondary as well. So we'll click save here. And we can go to CARP failover. Oh, we don't have any CARP interfaces yet. So one thing we can do is click refresh here. And we see that the sync rules, the sync firewall rules have shown up over here automatically. That's pretty cool. That's pretty nice, right? Okay. So now that we have the high availability sync set up, we need to start creating our virtual IPs and the CARP interfaces. All right. So how we create that is we go to firewall, we go to virtual IPs. We don't have any defined yet, so we'll click add. And this is going to be a CARP IP. The interfaces is going to be on WAN. And the address, we're going to use our own. Now, I can use really whatever I want here, but in your production environment, you're going to need to make sure that you have an available static IP address through your ISP that you can use here. All right, so 192.168.80.51/24, and the virtual IP password. Just make it, you know, something. This is what would actually allow other clients to communicate within this VHID group. So it doesn't really matter. You can kind of pick whatever password you want as long as it's the same in both of these fields. You only have to put that in one time here on this page because it's going to sync automatically over to the secondary firewall. All right, the VHID group. You want to make sure that the VHID group is different for each different interface. Okay, so you never want to double up on the VHID group and have two IP addresses that you're using for CARP within the same VHID. All right, so a good practice here to make sure that you never use another one, besides looking to just check and make sure that you're not already using it, is to sort of follow something with the subnet or something within the range here of the IP that you're setting to. So one thing that I notice is, we're using .80.51, so I'm going to set the VHID group to 80. You could leave it 1 if you want to. That's totally fine. You could pick any other number that you want. It's not going to matter. You just want to make sure that the number you select here, when you're setting up another CARP IP interface, that you're not using the same VHID group. So this is a good practice to follow. All right. So that's that. Now, advertising frequency, this is going to be 1 for the base and 0 for skew, and just leave that for the primary. And just, give a description here. This is our WAN VIP, and we'll click save, and then we'll apply. And we see it show up right here, 192.168.80.51/24, VHID of 80 on the WAN interface. The type is CARP, and there's our description. All right, so if we go to interfaces now, or virtual IPs on the secondary firewall, there it is. It's automatically there. How cool is that? All right, so basically what that means is now 192.168.80.51 is present on the WAN interface. Okay, so anything that's also connected to that network could also see 80.51. There also now is a new virtual MAC address that is associated to that IP. And the MAC address is actually what specifies what that MAC address is going to be is the VHID group or the VHID number that you set will actually change the virtual IP MAC address. Okay, so if I were to change this VHID to 90, then the virtual MAC address would change. All right, so I do need to put this somewhere in here. I probably should have done this at the very beginning, but when you get this set up and the sync is happening from the primary to the secondary, you always want to make sure that the changes that you make, you do on the primary firewall so that they can sync over to the secondary. If I would have created a firewall rule on the secondary, not only would it not be synced over to the primary firewall, but it would actually be removed. It would be overwritten by the primary firewall the next time that the rules get updated and pushed to all of the interfaces. So it actually would remove them. So don't make that mistake. Don't make a lot of firewall rule changes and do them on the secondary server so that they all just get blown away, and then you're like, oh no, I have to redo all of that again. Same thing for DNS and DHCP server changes and customizations. Do all of those in the primary server. Really, the only thing you're ever going to do in the secondary are system-related things, and then just maybe checking to make sure that that everything is good. So now that we have a CARP VIP set up, if we go to status and we go to CARP failover, we'll see that correctly the primary firewall has taken the master role. And if we go to the secondary, this has correctly taken the backup role. All right. And it sort of gives us a little bit of information about the IP itself and the interface that is on. You'll notice these two buttons here. So temporarily disable CARP and persistent CARP maintenance mode. They basically do the same thing when you click the button, but the difference is a temporary disabling of the CARP interfaces will not survive a reboot of the firewall. So when the firewall restarts and comes back online, it's going to turn all the CARP interfaces back on automatically, okay? If you do the persistent CARP maintenance mode, it's going to also disable the CARP interfaces just like this button would too, but it will survive a reboot, okay? So when you click this button right here, the only way to turn the CARP interfaces back on is to disable the maintenance mode. Okay, so a reboot is not going to turn everything back on automatically. That's the difference. That's the only difference between temporary and persistent. All right, so I'll actually click on this, and you'll see how the button changes to leave persistent CARP maintenance mode, and so this should come back to master. And so what's happening here is when you disable the CARP interface, the firewalls are talking to each other, and the primary one basically says the CARP interface is now offline. Okay, so you'll see that that didn't really refresh. This one would have gone to master while this one was down. Okay, and so now that we've disabled the maintenance mode, this one comes back to master. So let me actually show you that, and I'll refresh the pages so you can see how it changes. All right. So persistent CARP maintenance mode means we turn off the CARP interfaces here, and if I refresh this firewall, well, I thought that would actually switch over to master, but I guess it's not. Okay, there it goes. All right. Now, this this is where it gets tricky because a lot of people, well, not a lot of people, but there have been reports of some issues with some setups. Both pfSense servers want to stay master, or since there's a communication issue, they both will fall back to backup, and they won't come out of that role. So anyway, that's basically how you can sort of do a demonstration on, doing the CARP maintenance mode and watching how the other one will take over and switch from backup to master, and the other one's going to go from master to backup. And it's pretty neat to see how that works. So I just refreshed the page over here, and now we're back to backup and master like we're supposed to be. All right. So with that now off the list of things that I just have in my head of things that we need to cover, what could possibly go wrong, right? We will go ahead and let's see. So this is going to stay there, and we could go ahead and do the virtual IP for the LAN side as well. All right, so we're going to go back to firewall virtual IPs. That's where I just went. We'll click add. It's going to be CARP. This one's going to be on the LAN side. And the IP address is going to be 192.168.56.1/24. All right. And the VHID group, I'm going to do 56 because to me, that's just what makes sense. All right, and again, 1 and 0 on the base and the skew, and we'll call this VIP LAN. You can call that whatever you want, just something descriptive, something that down the road, either you or maybe not you, when they read this, will understand what it is. Okay, so be descriptive because 6 months from now, you're probably, if you have a lot of interfaces, you're not going to remember it, or whoever replaces you might inherit this system, and it would be nice if they could see a description and actually know what's going on. It's kind of funny that I reversed those things, but it doesn't matter. So there was one other thing that I forgot to mention. What was it? It's a very important thing. Well, hopefully it comes to me before the end of this video. Okay, so we've created the virtual IPs. We can verify. It's over here now. Okay, very cool. And now it is time to start doing some adjustments on the outbound NAT and also on the DHCP server. All right, so which one do I want to do first? Let's go ahead and adjust the DHCP server. All right, so DHCP, I actually don't have it running, but it doesn't really matter. Pretend that this box is checked and I'm actually using DHCP on this interface. Everything is going to stay the same as far as up here, but you'll notice that if you don't specify a DNS server on the configuration page, then the DNS server will just automatically give out to the clients the IP address that the DHCP server is running on. Okay, so for example, the DNS server would by default be 192.168.56.2 because that's the interface IP address of this interface. Okay, so but we don't want that, right? Because 56.2 is just the primary firewall. Okay, so if everything is pointing at 56.2 for the gateway and for DNS, if the primary firewall goes down, then all of those clients using .2 will stop working because they won't know of any other IP address to use. All right, so what we want to do is we actually want to change the IP that the DHCP server hands out for DNS and routing to the virtual IP. That way, if one of the firewalls goes down, the clients are using a virtual IP and everything will just be fine, okay? So we'll go to the DHCP server and we're on the LAN interface and we're just going to specify the virtual IP here, and we're also going to do the same thing for the gateway. All right, so that way, even if there's a problem with 56.2 and it goes away for whatever reason, the virtual IP is still online and happy. Now there's one other variable that we need to set here, and that is the failover peer IP address. All right, so we are going to set this to the secondary firewall's LAN interface. So it's 56.3. All right, so if we go to interfaces, we go to LAN, we see 192.168.56.3. All right, so there will be a DHCP server also running on 56.3, and we want to program that in here and say, hey, look, the failover IP address for the other DHCP server is going to be 56.3. Okay, but this 56.3 is never anything that ever gets put in on the client side. Okay, so like, you know, 56.3, 56.2, they're never really going to see that because we're using 56.1 for the gateway and for the DNS. All right, so that's it for modifying the DHCP server to work with high availability. It's pretty straightforward. The problem is when you have a lot of interfaces and you have to do a lot of overrides and a lot of customization, because you know, if you had 10 different interfaces here, you'd have to go into each one and set the correct IP address for all the different interfaces. Okay, so also make sure that you're not using this IP address on other interfaces for the DNS and for the gateway, because it needs to be the IP address of the actual interface that that you're setting up. Okay, so let's make sure that if I go here, DHCP server on the secondary firewall for LAN, we see that 56.1 was automatically put here, and the failover peer IP was automatically put here. All right, so that is it. We don't have to do anything for DHCP server on the secondary. And now I think the next thing to do would be go ahead and set up the outbound NAT. All right, so we'll go to firewall, NAT, and click outbound. All right, you have to switch to manual outbound because we can't really modify these rules because they're being automatically generated, and we can't use that. All right, so switch to outbound, and now we want to change the outbound NAT to use the WAN virtual IP instead of the WAN address that's actually on the interface. Okay, so if we don't make a change in the outbound NATing, when we send traffic to the internet, it's still going to be using and showing up as this, okay? Because that's the WAN interface IP that is assigned. Well, we need to change it to this, okay? Because the 80.51 will always be up unless both firewalls go down, which if that happens, we're gonna have bigger problems. But the 52 and the 53, those are the ones that are specific for the primary and secondary, and we don't want anything set up that is relying on one of these IPs, okay? Because if that 1 goes down, then the connection will go down with it. So we're going to use 80.51, which we don't have to program that in here. This will show up automatically. And let's say we click the edit button on there. And then the translation address is the only thing we have to change on here. So it says interface address, which in this case would be 80.52. And again, that's not the one that we want to use. We want to use the virtual IP address. So we just click the drop down and we say there's the WAN VIP. Use that, save, and change the other rule here. Where did it go? There it is. Do the same thing. Change the translation address to the WAN VIP. Apply. And now anything in the 56.0 subnet, when it hits the firewall, will use the NAT address of 80.51 instead of 80.52. Okay. And to verify that the manual outbound NATing is set up, which I don't remember if it actually does that or not. Let's check and see. It did. It switched from automatic to manual, and then it also went ahead and modified the NAT address for the subnet that we wanted, to do. So that will take care of the traffic using the virtual IP for the WAN side as it's hitting the internet. Okay, and you could do different IPs. So let's say we had a few extra external IPs, and we wanted different subnets within our network to use different external IP addresses as it's using the internet, as that traffic goes out and comes back from the internet. We can do that. You can actually just go to Firewall, Virtual IPs, and you can click Add, and you could put another CARP address on the WAN interface and set it up. And let's say we had another network. Well, again, we don't want to do it here on the secondary. We want to make sure we do everything on the primary firewall. You can just keep going, further and further with as many external IPs. And when you go to Outbound NAT, you could, as you have your networks show up here, you can just keep changing the NAT address to whatever external IP address that you want it to be set to. So you could sort of segment the traffic that way if you felt so inclined. Oh shoot, I just remembered what that was, and now I've forgotten it again. There is something very important. Oh, let's see if I can remember it. Let's see. I feel like it was in. There's just one more thing that you want to make sure is the same on both. I'm just going through these menus just to make sure. I guess it's not in here. Oh, there's so many things. It's like, okay, I know I'm forgetting something. Let's check the CARP failover and make sure that we're master and backup. Okay. Oh, I know what it is. Okay. I'm going to go ahead and do it now. We're going to sort of switch gears a little bit so that I don't forget this again. And it actually, this is probably good timing to do this. So we're going to go back to virtual IPs. And we're going to check it here as well. Firewall, virtual IPs. We're going to take a look at the WAN. Now, in the pfSense documentation, it correctly specifies that if you set up a base of 1 and a skew of 0 on the primary, then it'll automatically calculate that the secondary should have a base of 1 and a skew of 100. And basically what this means is the frequency of which things are going to talk to each other to determine whether they should be master or backup, okay? So if you were to change the skew of this from 100 to 0, and they were both 1 and 0, that would be a very bad thing because they would be fighting each other. They would both be saying, hey, I'm supposed to be master, you're supposed to be backup. And the other one would be saying, no, I'm supposed to be master, you're supposed to be backup. Okay, so you would just have this constant sort of like battle, and then really bad things would happen, obviously. It would not work. You probably would end up with the virtual MAC address on the network actually having the same IP in 2 different places connected to it. And that's not a good thing, okay? You can't have 2 network devices with the same IP address and the same MAC address connected to the same network. That's just not going to work. That's sort of, networking 101, right? So this is correct, 100. However, for WAN interfaces, and the documentation does spell this out, and I guess the same is true even for LAN interfaces as well. And I'm just realizing that this video is going way longer than I anticipated. Maybe we will hit that hour. Who knows? Anyway, the skew on the secondary, I have noticed on WAN connections specifically, 100 in some cases is not high enough. It is not far enough away from the skew of 0 to be stable. And what can happen, and the documentation, talks about this too, what can happen is you'll still have the fight over control. Who should be master and who should be the backup? So what pfSense recommends, or not pfSense, what Netgate recommends you do is you increment this number by 1 and try it until you reach a stable situation where things aren't fighting each other for that master role anymore. And don't change it, click save, and then look in the system logs, and 30 seconds later go, oh hey, it's fixed, because the stability may appear as if it's fine, and then 5 minutes later, 10 minutes later, 30 minutes later, an hour, a day, whatever, later, you could run into a situation where somehow it's out of control, and they're both fighting for master, which means there's a broadcast storm, and then the link goes down, so then they both sort of fall back to backup, and it's just a very bad situation. Okay, so what you may want to do, when you're testing and everything, is start at 100 and just see if everything is fine. And I have not noticed any issues on the LAN interfaces of having a skew of 0 and 100 for primary and secondary. But I have noticed issues on the WAN side with this setup, and I kept incrementing, 1 at a time. And I ended up at 110 on one of the WAN interfaces because that's what it took to make it stable. And now that it's stable, everything is totally fine. It's working beautifully. But getting to that point is sort of tricky because even the Netgate documentation basically says, look, each situation is different and custom, and it's nothing is ever exactly the same in every network environment. So you sort of have to play it by ear. It's a trial and error type thing, and just just know that when you're looking at the virtual IPs and the skew on the secondary, the primary should always be 1 and 0. Okay, so this, you're not going to increment the primary. Just leave that 1 and 0 for sure. It's never going to change. Where you're going to increment is on the secondary. Now, this just so happens to be a change that you actually do make on the secondary. Okay, so if I change this to 103 and then click save, it's actually going to stay 103. The primary is not going to override and make a change back to 100 on the skew. All right, so we should go take a look at it, and there it is. It's still 103. Okay, so if you're having stability issues, if you're having problems, after a while, or maybe just as soon as you set everything up, it's just not working, and you've got two masters, or your master is set to backup now, and your backup is set to master, and you can't get them to reverse back. Check the skew on the secondary firewall and start adjusting that, and maybe give everything a reboot, and after you adjust the skew, give everything a refresh, and then just see, does the problem go away? Does it still happen but less often? And if so, then knock it up another number. Just keep going, and eventually you'll get to a number, and all the problems will go away, and you'll be fine. All right, so I'm just going to double check and make sure that we covered everything, and that all of the CARP IPs or the failover setup looks right. Okay, so that's master, that's backup. We did set up the manual outbound routes to start utilizing the virtual IP. I think I said this, but maybe I didn't. For every single network, and this is where if you have a lot of VLANs and a lot of interfaces, it starts to become kind of a pain, because you have to go and change all of the translation addresses for all of those rules. So let's say you had another subnet that was on a different interface or was on a different VLAN, whatever. You have to do the change that we did here, where we click on this and then change the translation address to the WAN VIP. You have to do that for every single interface and every subnet that you want to actually use the virtual IP on the WAN side. All right. If you don't, if you just leave it alone or change some and don't change other subnets, the subnets that have not been changed or tweaked for the translation address, if the firewall, for whatever reason, goes down, those clients, those servers, whatever the device is, won't work. It will not find a way to get to the secondary firewall and then use the WAN VIP, which is kind of a waste. You do all this work and get all that far, and then you don't change the translation address on some of the subnets. They're not protected. They're not fully protected until you change the translation address here to the virtual IP address. All right, and I'm sorry if that's confusing. I hope that I've worded everything correctly, and hopefully everyone can follow this, and it's just not just really random things just sort of spewing out of my mouth, and hopefully you're not too confused. But if you are, feel free to leave comments and on the video, and those. Actually, some of the discussions that have happened on my videos are pretty neat to see everyone interacting and helping each other out. Let's see, is there anything else? Oh, so if you have a VPN set up, let's go through here and do one real quick. Save. There's gonna be things that I need to set. Pre-shared key. Generate a new pre-shared key, remote gateway. What? All Well, it's been a little while since I've set up that. Okay, so I'm thinking 51. Remember, we're using the virtual IP here for the public address because we want our VPN to also be protected. Okay, so if the VPN is running on this interface, this IP address, then again, if we're using that IP address and the primary firewall goes down, the VPN is going to stop working. All right, and then the same goes if we use this on the secondary. It's not going to work if one of the firewalls goes down. Okay, so again, we want to use the virtual IP everywhere that we can for all routing and all the services. And maybe I can create this now. Apply, yay. Okay, I'm not going to use this obviously. I just want to get to the right menu. Okay, so if we go edit this now, the interface here, we want that to be the WAN VIP. All right, so that's all you have to do. That's all you have to do to get the VPN to work on the virtual IP address. And then there may be one other thing as far as the firewall rules for IPsec. Or maybe it's NAT outbound. Okay, so for IPsec, if we do any, well, this is a bad idea. Don't ever do, don't do a VPN connection with any. It's not default gateway that we want to change. Apply. I feel like there is a I could be wrong about that. I thought you maybe would have to set something for the VPN network, but I don't think so actually. So if you go to IPsec, and the same thing works for OpenVPN as well, just make sure that the interface that the VPN is listening on is the virtual IP. That way, if one goes down, one firewall goes down, it's still going to be working on the other firewall. All right. And let's see, there's one more thing actually. I keep thinking of things. There's a really cool thing that you can do with the virtual IPs. Instead of every time, like let's say you had, 10, 20, 30 WAN IP addresses that you wanted to be CARP. You wanted them to be of the type CARP. You don't have to keep coming here and clicking add, doing CARP, WAN, and then putting in the IP address here. What you can do is do an IP alias. And instead of the interface being WAN, go ahead and choose a pre-existing VIP for this IP alias to basically be associated to. So here we are, here's our WAN VIP. And then we'll go ahead and put in our other external IP address that we paid a lot of money for, more than likely. So we've got 80.60, that's another external IP address, whatever. Instead of doing another CARP interface and letting that reside on the WAN interface, we can do an IP alias and use the pre-existing WAN VIP as the interface. Now what this does, it keeps you from having to define another virtual IP password. It keeps you from having to define another VHID group. There's no advertising base and skew to adjust because it's going to use all of the same settings that the WAN VIP is already set up to do, and it will actually fail over instantly the moment that this CARP interface would have switched from master to backup, or from backup to master. All right, so you can put as many IP aliases on an existing CARP VIP as you want. And the really cool thing is that one interface and the one VHID group, and basically this right here will control all of the other IP aliases that are associated with it. All right. So what that does is eliminates a lot of traffic on the pfSync interface. You know, it's a lot less heartbeat traffic, because for every single CARP interface that you have, pfSense is monitoring that. The pfSync interface is actually doing a lot of communication back and forth. So if you had, you know, 15, 20, 30 interfaces that that you needed to virtualize basically and set up as CARP interfaces, that would be a lot of traffic, and you would have to, you know, maintain a lot of VHID groups and have to make sure that the skew was adjusted for each different one. But this running as an IP alias on the WAN VIP that already exists is a way to basically click IP alias, put in the external interface here, and put a description in, and just make sure that you're running on the WAN VIP, click save, and you're done. All right, so we'll do that. I didn't put a description in, but that's okay. This is just for testing. And so we see it show up here, and if we go here to Virtual IPs, there it is right there. And you'll see that it's a little bit different. Okay, so it's an IP alias, and but the interface shows as the WAN VIP, and there's no VHID associated with it. Okay, it doesn't need one because it's basically just riding on top of the WAN VIP that exists here on VHID 80. All right, so once you set that up, it is let's see here. It will show up in the port forward if you want to do port forwarding. So interface, destination, it'll show up right here. All right, so you could say anything that was coming in, you know, to 192.168.80.60. There you go. Go ahead and forward it. So it becomes, there's really no drawback to using an IP alias and associating it with an existing VIP. You know, there's really no reason not to, except for the fact that if you had different physical interfaces for these different WAN IPs to be on, then that's where you would not want to basically put them all on one VIP. Does that make sense? Hopefully that makes sense. Because you could have a setup where you've got maybe switches set up also in high availability, where, you know, half of your WAN traffic is going to go through this switch and the other half is going to go through that switch. You really would want to just, you know, make sure that that you're not putting everything on one interface if you have the option to sort of spread it out between different ones and different switches and that type of thing. All right. So I think that has pretty much covered it, and that's probably like the 10th time that I've said that. And I don't even know how long this video is, but I feel like it's probably long enough, and we probably covered just about everything that I can think of right now with the oh, this is interesting. Why is that happening? Oh, just when I was about to finish up here. So basically this should not be master. All right, so if I go to No, I don't want to change it here. I want to change it here. So that's interesting. Wait, that is, let's check. It's the WAN interface that is getting confused. Okay, so maybe this is like a pfSense bug or something. I don't know. This is 244p3, I think. Yeah, 244 release p3. I don't know. I mean, this is very bizarre. I've seen this before. So anyway, I'm glad it happened because I can actually show you what exactly is happening. So if we go here, CARP failover master master, CARP failover master backup. The backup is right, but master should not be. So I wonder if I go to system logs and see, here are a lot of things in the log that are showing us that some really bad things are happening right now. So CARP has resumed, or WAN has resumed CARP state backup for VHID 80. And it's basically saying that it's flip-flopping. You can see first it's backup right here. And then, okay, so that's at 1229.03, and then at 1229.05, the same thing now thinks that it needs to be master. All right, so we're going to fix this. We're going to take care of this. If I go to Virtual IPs and go to this one and bump this up to, just to save a lot of time, we're going to bump it up to 110. Save, apply, and let's check CARP failover. Back to backup. Let's check this one, master master. All right, and then we'll go to system logs, and we should see all of this craziness right here go away. All of the fighting back and forth and saying, oh, I thought that I was supposed to be master, and I'm actually being demoted back to backup now. What happens too to start causing some of the triggers is if you look at the system log for the gateway, yeah, here's a lot of weirdness that is a side effect of the two masters being online at the same time. Is you know, weird random things start happening. So here's some info on that. Packet loss, 1,000 millisecond latency alarm, blah 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 blah. And if you were to go to status gateways, this probably would have shown packet loss, you know, 10%, 20%, whatever it happens to be. And actually, you know what? For fun, let's go ahead and trigger that. Let's trigger this. Let's do something crazy and do something we should definitely not do. Let's set this down to, can we do 0 there? Sure, let's do it. Save. This might break everything. This might like crash the whole thing, and I may not be able to get back into it. So status, system logs. Now things are really going to get fun because we're just intentionally like just seeing what would happen now. All right, so backup, refresh. I don't know how long that's going to take before things start going very bad, but they will. And I may have to end the video. I don't know how long it's going to take. I would imagine it wouldn't take very long at all. Let's just make sure. Yeah, 1 and 0, 80. Yeah, that should start causing problems. We'll wait for it. I was hoping I could trigger the two interfaces being online at the same time, but it may not play nice. You know, when you want to break it, it's probably not going to break. I'm trying to show you guys how to do this and giving you an example. And of course, doing the absolute worst thing possible is probably not going to cause a problem, but we'll see. Yeah, I mean, well, we do, yeah, this is starting to look not very good. But part of the problem could also be that all this is virtualized and, you know, it's it may not, since it's not a real world situation, it may not be behaving exactly like I expected. But if we go to status, gateways here, okay, maybe if I change this to maybe it has to be something greater than 0. Okay, it has resumed backup. That's actually, going back to backup is right. So, yeah, if you've watched enough, feel free to turn the video off now. I'm actually going to maybe leave this running and try a few things. I don't know why this isn't breaking catastrophically when it should. But anyway, before I leave that and forget that, I'm actually going to turn that back. So that the next video that I try to do, when it's all breaking and hitting the fan and I can't figure out why, then I don't have to worry about that next time. All right. So I tried to break it and I can't even break it. That's how good I am, I guess. I can't even break things the right way. So thanks a lot for watching. If you've made it through this probably ridiculously long video explaining CARP IPs and pfSense high availability and all that fun stuff. If you're doing this in an ESX environment, VMware, whatever, make sure you read up on the documentation because there's some extra things you have to do with promiscuous mode and all that stuff. And the NetGate documentation is really good about kind of walking you through that and troubleshooting some pretty common flaws with setups that people have that they're kind of running into issues with the pfSync maybe not communicating or it's unstable. They've got some pretty cool things that talk about different network drivers and different issues that there could be and things that you can try. So thanks for watching. I will try to make another video sometime within the next 6 to 12 months, and I guess we will go from there. I'm not exactly sure what that video is going to be yet, but as soon as I find out and as soon as I record it and upload it, you will find out. Thanks for watching.